Hey everybody, welcome back. So this is me picking up where I left off with the EECS 370 exam review. We're looking through the fall 2021 exam. But yeah, today we're going to be working on struct alignment. So the main ideas of this type of problem is to evaluate your understanding of um, the representation of different data types, as well as structs in memory, as well as a little bit about like how the size of structs and the type of structs or data types impacts their alignment and where they start in memory and how that can impact optimization in terms of utilization. So we're going to go ahead and get started. So what I like to do when I approach these questions is first just kind of go through and label the sizes of each of the primitives. We're not going to be able to determine the size of the structs just yet, but we can determine the size of the primitives. And so the things that impact that is just really the type of the operate or the type of the architecture. And so here we see that we're running on a 64-bit architecture. And so this 64-bit architecture affects the sizes of certain data types. And so the one that comes to mind is pointers. Pointers in 32-bit are 4 bytes, but in 64-bit, they're 8 bytes. But let's go ahead and get started. So the first variable that we have here is a short a. So short, I like to think of it as like a little bit shorter than a normal integer, which would be 4 bytes. So in this case, it's going to be half of that. So it's going to be 2 bytes wide. Next, we have integer b. So integer b will be 4 bytes wide. So this one is tricky because while it says int, right, it's not actually an integer, it's a pointer to an integer, right? And so that's going to impact how big it is. So remember, a pointer is 8 bytes wide. But this isn't just a pointer, this is an array of pointers. In fact, it's going to be an array of length 4. And so when we consider how large it is, it's going to be 4 times 8. And so we're going to get 32 bytes. We don't know how our bigger struct is going to be because we haven't done alignment, but we can continue. So then we have this char. So all chars are going to be 1 byte wide. And then we have another short again here. So it's 2. That was the correct 2. Let's try that again. Awesome. All right. So now we can start from the start with the addresses. So our outer struct here is going to start at address 1000, and we don't know where it's going to end yet. So let's go ahead and start with the first variable that we have in our structure. It looks like it's a, and so it can go at the very beginning. We just need to make sure that the size is a multiple, or I guess the starting address is a multiple of the size. And so 2 is just fine. So the end address is going to be 1000. Okay. So then we look at our data structure and we have a struct. So remember, a struct alignment is determined by the largest primitive in it. And so the largest primitive we have in this inner struct is going to be an integer pointer, which is 8 bytes, right? So our struct for inner needs to begin at a multiple of 8. And so the next multiple of 8 that we have available is 1008. And so we're going to start at 1008. And so B, because it's the first member inside our struct, is also going to start on 1008. So B is 4 bytes long, and so it's going to end at 1011. Awesome. So then we have our array of pointers. And so the primitive in here is just the pointer. And so that needs to be aligned with a multiple of 8 bytes. And so the next multiple of 8 bytes that we have available is 1016. And so that's going to be 32 bytes long. And so we can calculate where it ends at 1047. Awesome. But remember, we might want to just, move that in there, but this is tricky because the struct inner, the entire size of that struct also needs to be aligned with the largest primitive. And so the largest primitive in here again was 8 bytes. And so it, instead of being 36 bytes long, it needs to be 40 bytes long. And so let's go ahead and luckily in this case it works out, but you got to be careful because there are cases that won't. In fact, if I just look at this question a little bit longer, I think it might apply later, but we'll get to that. All right, so then our char can begin right after our inner struct. And it's only 1 byte long, so it should be pretty simple. Then we have a short, and so it's a multiple of 2, and so we can't start it on 1049. We need to start it on 1050, and it's going to be 2 bytes long, and so it'll end on 1051. All right, so now we, again, might want to move that in there, but we can't because it needs to be of a size that is a multiple of the largest primitive. And so the largest primitive that is in outer is going to be that 8-byte nested pointer. And so the next, I guess the next size that would be available would not be, what would it be? Currently it would be like 52, but we don't want it to be 52, we want it to be, the next one would be 56. And so our ending address would be 1055. Awesome. So yeah, that's all there is to this question. But that's all I have for this video. Hopefully you guys check out the next one where I will be discussing, assembling and linking.